Hey guys, I'm just going over here the notes for chapter 9 or unit 9 section 2, which corresponds to chapter 7 in your book, your textbook. So chapter 7 section 2. We're talking about inverses of relations and functions. So inverses. We're going to talk about how to graph inverses and find them. And it says we've used, and by the way, these I posted in the Google Classroom, so you can print these and do them right along with me. I highly recommend that. So you can refer back to them without having to pop open the video again, or just keep popping open the video, whatever works best for you. It says we've used the word inverse a few times this year. We've talked about additive inverses, multiplicative inverses. We used inverse operations when you're solving for a variable. But now we're going to find inverses, relations, and functions. And to graph the inverse relation, you can reflect each point across the line y equals x. We'll show you that in a second. This is the equivalent of switching the x and y values in each ordered pair of a relation. So here's a couple of examples. We've got this table of values, right? And we're calling this our original, if you want. So this is our original. And let's go ahead and plot those. Let's go ahead and put those on the graph here. So remember, you always plot x comma y, right? When you're plotting a point, x and y. So this is the point 0, 2, right? So 0, 2 is right there. The point 1, 4. We've got the point 2, 5, 4, 6. So be careful. 4, 6, 8, 7. Okay, so 4, 5, 6, 7, 8. That was 6, so 7. And then we're at 12, 8. Let's see, that was 8, so 9, 10, 11, 12, 7, 8. Okay, and let's go ahead and connect the dots. We're not going to make it go further because this is kind of a weird looking function. Oops, and I didn't draw it beautifully, but whatever. So we're connecting the dots there. Just getting that kind of general look there. So this is the original. And then what happens with the inverse is, like it said there, you're going to reflect it about the line y equals x. Well, let's plot that line y equals x, or graph it. You know, graphing this line, this is in the form y equals mx plus b, where m just happens to be 1 times x, and b happens to be 0. B is the y-intercept. So we're going to be going through the origin, y-intercept is 0, with a slope of 1, which means it's just that really nice straight diagonal, you know, well, all lines are straight, but through the diagonal here, like so. So a nice perfect diagonal slope of 1 through the origin. That's the line y equals x. And so what it's saying here, what it's set up here, is that it's reflected across that line. So every point will be the same distance from that line as it was to begin with. So this point, you know, if you kind of look at these little diagonals here, is 2 diagonals away. So 2 diagonals away on the other side should be the other point. And you can kind of just check that. I'm going to graph them right here. This guy was just like kind of a half a box away right there. This one on the other side, right? 1 full box away. This one like 1.5. Another 1.5. And then a 1. And so if I connect those, again, I'm not doing this beautifully, but do the best I can. You get that reflection, right? We know reflection. We've talked about transformations before, so we reflected over this line and look at what happened doing that. And here's the table over here for the inverse, right? We're going to be at 2, 0 right there, 4, 1, 5, 2 right there, 6, 4, 7, 8, and 8, 12. And if you look at the two tables, what essentially happened, your x became the y's, and the y's became the x. They essentially swapped for this inverse. It does say, so graph the relation, we did it, connect the dots. Graph the inverse relation, did it, connect the dots. Identify the domain and range for both relations. So for the original, the domain, remember, domain is the input values, your x values, so 0, 1, 2, 4, 8, 12. But we connected the dots, and so we are going to say everything in between. So if we're using interval notation, we're going to say from 0 to 12 with our kind of square brackets to show that we include 0 and 12. So the domain is from 0 to 12. The range is your output, your y values. Looks like we're going from 2 to 8. Okay, and for the inverse, same idea. We want to get the domain and range. The domain here now is 2 to 8. Using, again, that interval notation. Remember that from a while ago. And the range is going from 0 to 12. And so there you can see it again, right? Domain and range have swapped. Range and domain have swapped. Is what's happening with these inverse functions if you're thinking about their graphs. But let's talk about how do you find it? How do you find the inverse if you're just looking at a function like x minus 4, or like this guy, 2x minus 3 over 4. How do we do that? And so here are the steps. These are the steps. So these are two different examples. Here are the steps. By the way, we write the inverse function as f to the negative 1 of x. Now this is not actually to the negative 1 power. This is just a way of us saying it's the inverse of what f of x was. Here's f of x. This is f of x in f of x's inverse. Okay? Here's what you do. Rewrite f of x as y. Swap f of x for y. F of x for y, right? We swapped f of x with y. Then switch the x and y variables, right? Look over here. It was y equals x minus 4. Now it's x equals y minus 4. Over here, y equals this fraction. Now it's x equals the fraction with y where x was. So step 1, swap f of x and y. Step 2, switch places with your x and y. And then step 3, now solve that equation for y. So get y alone. So like over here, the very simple linear one, I've got y minus 4. So what do I do to get y alone? I add 4 to both sides. So now I get y equals x plus 4. Now rewrite y as f inverse. So go back to the function notation. So y equals x plus 4 is going to be the inverse of f of x is equal to x plus 4. And so if you look, f of x was x minus 4. Its inverse is x plus 4. Okay. Over here, when we swapped the x and the y, we're going to solve for y. So what needs to go first? We're going to multiply both sides by 4. That's what's happening here, because then that makes those 4's go away. And so you just have a 2y minus 3 equals 4x. Add 3 to both sides to get a 2y equals 4x plus 3. Divide by 2, and you've got this 4x plus 3 over 2 equals y. Swap y with f inverse. So f inverse is 4x plus 3 over 2. Note, look at the difference there. Right, the original function, 2x minus 3 over 4. The inverse, 4x plus 3 over 2. So very interesting concepts here. So let's do a couple. Let's see if we can do a few of these. So on the next page, let's try a couple inverses. All right, we'll follow those steps one by one. So first step said swap f of x for y. So instead of writing f of x, I'm writing y now. X over 4 minus 5. Okay, so that was step 1. Swap f of x with y. Now step 2, switch the places of x and y. So this will be x equals y over 4 minus 5. Okay. Now that I've switched places, now solve for y. So when you get y alone. So what would I do first? I'm going to get rid of that 5 by adding 5 to both sides. And that'll give me an x plus 5 equals y over 4. Okay, and then the last step then, I'm going to multiply both sides by 4. Now be careful, this whole side gets multiplied by 4, so there's going to be a distribution here. Okay, multiplying by 4, I mean, those cancel. That's why we did it. So we just are going to have y. This will be a 4x plus 20 if I distribute that. Okay, and then we usually tend to write the f inverse first. So, and then we, last step, swap y for f inverse. So f inverse of x equals 4x plus 20. So this, 4x plus 20, is the inverse of x over 4 minus 5. Okay, so what would happen if we graphed both of these? We would see, like we did right here, we would see this reflection over this line, y equals x, for these two functions, f of x and its inverse. Okay? Let's do another example. All right, so again, replace f of x with y equals 2x. And then we're going to swap x and y. So x equals 2y, and then solve for y. We divide by 2 to get y equals x over 2. Replace now y. We're done. We've solved for y, so now replace y with f inverse of x. So f inverse of x is x over 2. All right. In interest of time, YouTube is only allowing us to do 15-minute videos, and so since we're approaching 12 minutes here, I'm going to go ahead and stop here. I'll make another video for completing the back of this notes page. So let me stop it here, and we'll do the other examples on another video.